Hi guys, so it looks like we're on a definitive rule today, and that's how it usually goes with differential equations. When you start, you just gotta maintain the flow. And I hope this is the way you guys have been reviewing the videos, because sometimes when you tend to take too long of a break in between, you tend to lose that flow, moving from first order to second order to non-homogeneous to different types of non-homogeneous functions. So it's always helpful that if you took a long break in between them, that you go back and you review what does auxiliary equation mean, what does a complementary function mean, and so on. So on screen for today, you can see that we have the standard second order non-homogeneous differential equation. And in particular, we are going to be looking at that right-hand side and when our function is of a certain form. Now, last session, we looked at the forms where we had polynomials either being constants or they were either increasing values of x. Today, we are going to look at trigonometric functions where our right-hand side is some form of sine or cos. All right, so when our function is some form of a trig. So what's a general solution for a non-homogeneous differential equation when our function is a trig? Well, essentially, it's going to be the same, where your general solution is simply going to be equal to your complementary function plus your particular integral. What essentially changes is that particular integral. Because your particular integral is related to your function on your right-hand side, then that's the only factor that would change in your solution. So let's get into this, an example of a question. We are going to attempt to solve the differential equation of the form d2y dx squared plus 2 dy dx minus 3y is equal to 6 cos 2x. Now, because this is the only question we'll be doing in this tutorial, I am actually going to do the entire complementary function along with the particular integral. So our first step towards getting that complementary function involves firstly identifying our auxiliary equation as it's related to the left-hand side of our equation. Now, our auxiliary equation for this question is given by m squared plus 2m minus 3, and we are going to set this equal to 0. Now, you can solve this by basic factorization, and that gives us a value of m being equal to minus 3, and you'll also get a solution for m, that's m1 and m2. Make sure you differentiate your values of your roots being different. M2 has a value of 1. Now, because these roots are real and distinct, we will now have a general solution for this being of the form a e to the minus 3x plus b e to the positive 1x, or just x. Now, this is not a general solution because this question has a function on the right-hand side. So therefore, for this type of question that's non-homogeneous, this is called the complementary function. What we need to move on towards working out is our particular integral. Now, our particular integral is closely associated with our function on the right-hand side, And if we identify that our function is some form of a trigonometric function, then our particular integral takes a certain format. The format our particular integral will take looks as follows. Y is equal to lambda cos of, let's just say, let's call it alpha x plus mu sine of alpha x. Now that value of alpha comes from your function. So if we go back to our function, we can see that our trig given in the question had an angle of 2x. So therefore, our alpha is 2. We are going to now use that information and rewrite our particular integral. Alpha has a value of 2 based on our trig function given. So therefore, we will write 2 here as well as 2 here. Now, the intention of a particular integral is always to find values for your constants, lambda and mu, or whatever you choose to call them. We will go ahead and differentiate. Our first derivative, dy dx, of this function will be minus 2 lambda sine 2x. Similarly, we will get plus 2 mu cos 2x. Upon differentiating a second time, we will get minus 4 lambda cos 2x plus 4 mu sine 2x. This will be a minus. Now what we have to do, we need to substitute all 3 of these values back into our original question. And we need to substitute it into the entire question, inclusive of the right-hand side. Doing so gives us, let me see if I can get this entire, I'm trying to get the entire question on screen. It's going to be, there we go. So substituting into our entire original equation gives us minus 4 lambda plus 2x minus 4 mu sine 2x plus 2 of dy dx. That gives us minus 2 lambda sine 2x plus 2 mu cos 2x. And then finally, minus 3. And because I don't have space here, I'll simply state that you will write y into this bracket. Then you will equate this to 6 cos 2x. Let's see if I can try my best to get that part on screen because it's very important. So we'll equate that to 6 cos of 2x. Now essentially what you do when you write out your very long statement is you try your best to equate coefficients of constants, of the term in x, of, in this case, trigonometric functions. So let's see what we can compare and equate. So we can see that we have some terms in cos 2x on both sides. And once you are able to write this out on your own, you should be able to arrive at comparing coefficients of cos 2x. You would get minus 7 lambda plus 4 mu would give you 6. Similarly, if you were to compare coefficients of sine 2x, you should be able to arrive at minus 4 lambda minus 7 mu gives you 0. Collectively, you can use these two equations and you can solve for values of lambda and mu. You can work those out on your own. For now, I'll state the values that you should get. Okay, so once you were able to do those basic simultaneous equations and solve for values of lambda and mu successfully, we can move on towards putting our final answer together. Remember that your final answer or your general solution involves adding your complementary function plus your particular integral for non-homogeneous second order differential equations. We found the complementary function earlier, so now what we're going to do is write out our particular integral. And our particular integral was given by y is equal to lambda plus 2x plus mu sine 2x. We found values to lambda and mu, so we will replace them here. Lambda had a value of minus 42 on 65, and similarly, mu had a value of 24 on 65. Now finally, now that we have the particular integral, we can simply write them together and add to get a general solution. And our general solution is going to look quite tedious, but it is correct. All right, so your general solution would end up looking as follows. Y is equal to e to the minus 3x plus b e to the x from before. That was our complementary function. And now we are simply going to add our particular integral in. So that's minus 42 on 65 cos of 2x plus 24 on 65 sine of 2x. And that is our final answer with our non-homogeneous second order differential equation. Be sure to tune in for my next video where I will be looking at functions on the right hand side that are of the exponential form. And if you guys would like to see more tutorial questions on trigonometric functions and how to solve them, be sure to leave a comment down below and I will be happy to do more questions for you guys. I hope that it's getting clearer and clearer. It's becoming easier to understand, and I look forward to seeing you soon. Take care and goodbye.